I'm going to tell you right now to go stick it with the right stick. Welcome to Turn Right Machine Works. My name is Keith. Today we're putting together and we're building some cockpit sticks. This one here is called the right stick, and the right stick is the most popular stick here on the Cape Cod, maybe even New England. At least that's what I've heard by the majority. I do also build harpoons, and I have a pair of those that we're putting together also. These are 12-foot harpoons. You can't even get to the end in here with the camera on that. And those, but they're basically all the same style of stick and use the same head, different lengths. I also have now a 3-piece stick that disassembles and can package up and put into a handbag. So here's a video of how I build my sticks and a few tips of machining along the way. Alright, our first step here is to turn this diameter down to a certain dimension that slips within the aluminum pipe that the harpoon heads are mounted into. The aluminum pipe is 3/4 schedule 80, and it has an oddball diameter. It's not a finished diameter, so it's we finished these off somewhere around 738 is our target diameter, and at this length right here. Alright, so we're going to go ahead and set it up, and instead of turning it with a tool bit in the conventional way, with the tool bit facing up, we're going to turn the tool bit over so that, and run it in reverse so that the brass sprays right down into a pile below instead of flying all over the shop. Alright, so I'm going to show you how I set up the tool bit here, and also to set it up on center, or its position in relationship to center is probably the better phrase here, because you definitely don't want to be on the opposite side of center. Then the tool bit's designed to cut. Alright, now of course we're gonna position it over here because that's where we're gonna start, and we want to be able to cut from the beginning here. So we got a little bit of clearance in here so our carriage can travel for the longitudinal feed. And alright, we're going to bring it over here. Now, to set our actual height here, because we don't know, this is above, that's below. Now you want to know right off the bat, unless you've pre-centered a tool bit and you have a flat surface like the carriage on up to the center and have that measurement. I have on this lathe here, I particularly wrote that down when I first got it. It's 6.30. But I'm gonna show you another way, and that is to take, I like the thick pocket scales, and putting just a slight tension between the cutter and the part. Now, if the scale leans on the top side, if it leans away from you, you're above center. If it leans towards you, you're below center. Alright, now it's more favorable for a tool bit upside down to be above center, but you want it as close as you can to center. So I'm going to see if I can lower this down slightly, and of course I'm up above this here. So I'm taking a parallel and sticking it underneath the adjustment nut here, so that I have something to gauge by, and I'm going to drop it down, retension it. Alright, we are slightly leaning back, but we're almost vertical, and I'm going to call that center. Now we're ready to cut. Alright, we're going to touch off, we're going to set our dial, and we're going to take our first cut on down here. And we're feeding our normal coarse feed here. 'Kay, our coarse feed is about 5 thousandths per inch in revolution there. Alright, let's grab our inside or our outside 1-inch mic here and see where we're at. Now that was 100 thousandths per side, and that took us down to 795. Okay, we're looking for about 7 thousandths off of that. 738. Alright, we're going to let this run, and we're going to finish the cut. We're going to go grab our piece of test tube. Our test tube. A little bit in the forward direction, and we give a little bit of chamfer there, a little bit of a chamfer there. Alright, and we're looking pretty good, maybe about 1/1000th under or so. We're going to check the fit on there. We get a knurled fit that goes in here that holds, and we cement the heads in as well. Now there's a couple different, the main thing is we don't want a rattly butt down here. We want it snug, and that's our larger diameter is down here, and when we knurled that, we'll bring that up as well. Alright, let's test it. Alright, here's our test tube. A little bit loose. Let's see what our veneers read. 737, 735. Alright. This whole one here. 733, 734. See how this fits in the tube. Same thing. Gets tight up there where the knurl goes. Alright, we turn the other end, and this end here, the name of the game is to go ahead and drill a clearance for a 3/8 shank, 1 7/8 inches deep, and then I take a D&M P here, and I turn it slightly so that it gives us the finished angle that I'm going to put on the leading edge of the harpoon itself. And this is to enter the water uniformly, smooth, without making bubbles, and it works out pretty good. Alright, so this is how it goes. Another thing, on this drill bit here, I I've ground a flat on the two leading edges of the drill so it doesn't grab into brass. And it makes little small short flakes. Alright, we're going to change out our drills now. We're taking out a standard drilling one, and we have a flat bottom, and we've kind of put a grind on this. It's very similar to an end mill. Of course, we did it by hand. Works very, very well. Alright, we've got the square bottom in here, and we've got our ways nice and loose. Now we're going to slide it in, and we're going to lightly lock our carriage right at the bottom and barely give it a twist in there, just to seat the bottom square bore. We empty it out, and I don't know if you can get a picture in there or not. Okay, we're set up here, and we have our knurling tool attachment on here, and we got the first part set up where we're going to perform the knurl. This is a sample part here, and that is the knurl there, and it's just enough. It doesn't have to be a pretty knurl. It's not going to be seen. All we're doing is raising the material up at this one location right here. So we do the 3M cement, and we slide it, we drive it right into the rod, and it's a press fit, and it holds it there till the cement cures. And that's how we mount our heads into the shanks. Alright, and you don't need high speed for knurl, and it's kind of a quick in and out process. Just holding it a couple seconds there, letting it roll, and then backing right on out. Especially with brass there, because brass is brittle, it'll flake. Alright, and that's all we need, is just enough to create an interference.